Hello everyone. So previously we had discussed on the topic AVL tree algorithm, right? So today we'll be discussing on the topic Bloom filter algorithm. Yeah. So let's get into the definition part here. So let's see what the definition part say here, right? The Bloom filter is a probabilistic data structure. So it's a probabilistic data structure that efficiently tests whether an element is a member of set, right? It's a probabilistic data structure that efficiently tests whether an element is a member of a set, right? It can tell you if an element is definitely not in the set, if an element is definitely not in the set, or possibly in the set. If it is definitely not in the set or possibly present in the set, that's what it can tell you, right? It can tell you if an element is definitely not in the set or possibly in the set, but never guarantees exactness, right? Allowing false positives but not false negatives. Yep, so this is fine, I believe. Let's move on with the explanation part. So first thing here, a Bloom filter uses a bit array of size m. It uses a bit array of size m, initially all zeros. Initially set to all zeros, right? It uses k independent hash functions. So Bloom filter, what it uses k independent hash functions just to map an element to k positions in the bit array, right? Just to map an element to k positions in the bit array, right? So when inserting an element, we set those k positions to 1. While inserting an element, we set those k positions to 1, right? So when checking the membership, what we do, if all k positions are 1, the element may exist, right? If only when all the k positions are 1, the element may exist. Otherwise, it definitely does not exist, right? So that this allows memory efficient appropriate set membership checks, widely used in the databases. Again, caches, this one AVL tree is also mainly used for the database indexing, right? It is also widely used in the databases, caches, and this one caches and network filters, right? So this is fine. These are the use cases actually. Yep. So now let's start writing the algorithm. Yep. So let's start writing the algorithm. First, I'll just go with here import math. Yep. So let me go with import. So I'll just go with the hash library. I'll just go with hash lib. Yeah. Next, let me go with a bit array. Actually, it uses the bit array itself, right? So I'll just go with here bit array. So this is not showing actually. So this is fine. Bit array. So why this is not showing actually? Just give me a second here. So let me do one thing. Let's make use of the library. So I'll just give you a pip install bit array, right? So let's wait for some time. So this will be resolved after this one gets installed, right? So just give me a second here. Let's wait for some time actually. So here, a new release of, so this is fine. Yep, now we have successfully installed this one, right? So let me give clear screen here. This one has to be gone now. One second. Let me give here bit array. Yep, so this is fine. Now let me do one thing. Let's move on with the other part, right? So first let's create a Bloom filter class, right? So I'll just go with class here. Let me go with Bloom filter. Yep, so this is fine. Let me do one thing. Within the class Bloom filter class, actually, let me go with the initialization part. I'll just go with init here. One second. So let me remove this one along with the self. I need some certain things actually. I'll just go with the size here. Also, I need the hash count as well. I'll just give the hash count itself. Yep. So this is fine. Let's initialize the bit array of the given size. All bits set to 0, right? I'll just go with the size here. Let me go with the size and let me initialize this one to the size. Next one is self dot hash count. So I'll just go with here. Let me type this one. This is not showing. So this is fine. Let me initialize this one to the hash count. Yep. So the next one is this one bit array, right? So I'll just go with bit array. So let me initialize this one to the bit array dot again bit array of size. Let me pass the size here. So this is fine. Again, the final one would be self dot bit array. Let me go with a set all here. Yep, set all of initially. Let's set this one to the 0 as per the explanation. In the explanation, we discussed the same thing, right? Initially, it will be set to zeros, right? So next, let's move on with the next step or the step two here, hashing an element with k. So let's go with or let's go by hashing an element with k different functions actually. Yeah. First, let's go with a function named hashing, or let me go with hashes actually. This is fine. Yep. So along with the self, let me go with the item here. So this is also fine. Hashes function. So within the hashes method or the function, first we have to generate the multiple hash values for the item. So let me set the results to the empty array. To the empty array. This is fine. So for I in range, so I'll just go with self dot. So this one hash count. So let me go with a hash count. Yep, so this is fine. Uh, let's combine the item with a hash index to get the unique hashes. Right, I'll just go with the digest equals hash lib. Uh, this one I'll just go with SHA-256 here. So this is fine. Hmm, let me go with item plus str. Let me go with item plus str of I. So this is also fine. Hmm, yes. Let me go with the encode actually. Let me go with the encode. I'll just go with UTF-8 here, standard encoding, right? So UTF-8, and finally, let me go with this one, hex digest, right? So I'll just go with hex digest of. Let me pass this one. That's enough. Actually. This is fine. The next one, we have to go with a map hash to a bit array index, right? So we have to map hash to a bit array index. So I'll just go with the index equals int of, let me pass the digest actually here. Yeah, digest. Along with the digest, let me pass the number 16 here, right? Modulo size. As we are making use of class, as we are dealing with the classes, let's go with self.size here. This is fine. And finally, let me go with the results here. And results, we have to append the index to the results, right? So I'll go with the append of what we need to append, index. So this is fine. So I'll just, yep. So this is fine. Final one is we have to return the results, right? I'll just return this one, results actually. Yep. So this is fine. The next step would be we have to add the item to the Bloom filter. For that, let's make use of the function add here. So this will be relevant. The name is relevant, right? Here, I'll just go with the self as well as the item. Yep. So within the add method, let me go with the for loop for index in hashes actually, and hashes, yeah, underscore hashes, the method name actually. I'll just go with item. So this is fine. So within the for loop, so this one has to be index. Yeah. Yep. So this is fine now. Now let's do one thing. I'll just go with the bit array. This has to show. Yep. Bit array of index. So let me set this one to the one actually. Yep, so this is fine, man. Next, let's do one thing. We are left with only one method, nothing but so check. What does the check method do? So it checks if an item may exist in the Bloom filter or not. Right? I'll just go with the check here. Check of, let me go with self, comma, item. Yep, so this is fine. Yeah, so I'll just go with a simple for loop here. So this one will be for index. So this is fine. And this one, hashes of item. Yeah, I'll just go with hashes of item. Let me pass the item. So this is fine. This has to be within the array or parenthesis. It has to be this one parenthesis, right? Of the array or the list. So this is fine. Yep. Within the for loop, let me go with a simple if condition. If this one bit array, let me go with a bit array here. Sorry. I'll just go with index. If it is equal to the value 0, then let me return false actually. Let me return false, right? So this is definitely not in the set. That's the reason we are returning false. Else, if it is possibly in the set, then in that case we have to return true actually, Boolean value true. So this is fine, I believe. Yep. So this is fine. So this one I have to go with this for drop, I believe, or else we'll be getting the wrong answer. Yeah. So let me format the document once so that this looks clean. Yep. So we are done with the algorithm part. I have explained you this one step by step. We have discussed this one step by step. Let me do one thing. Let me take the demo usage or the example usage from the Google. Just give me a second here. So let me paste this one over here. What we are doing, we are just first we are calling the Bloom filter class here, right? Size we are setting the 50 and hash count we are setting this one to 3, right? So this is fine. Next, what we are doing, we are adding the this one items to the filter, right? So we are adding the items to the filter, right? So this is fine. Um, what are the things that we are adding? Apple, banana, as well as the cherry, right? So the final one here would be this one. We have to check for the membership as well, right? Apple in filter, we are going with the check apple. So this we have to get true. Banana in filter, yeah, banana in filter. We are checking this one banana, true. Then instead of the cherry, we are going with a grape. Grape, we have not added grape at all, right? Grape is not in the filter. Yeah, grape is not in the filter. Grape in the filter. When we check grape, expected false most likely. Yep, we have to get the output false. So I'll just do one thing. Let me give here control J. Yep, so I'll just go with Python followed by the file name.py, right? So I'll just copy this entire file. Let me give you a file name.py, enter. See here, apple in filter true, banana in filter true, and grape in filter false because grape is not present in the filter. So we are getting the absolute correct output. We are getting the desired output. So whatever the code that we have written works absolutely correct. So no need of math, I believe here. We are not performing any math operation here. So let me type this one. Yeah, we don't need math. We don't have to import math actually. Hash lib and this one bitter is enough actually. Just give me a second. Yeah, this is fine. Now we are done with the coding part, and we have also discussed the this one. What do we call? What do I say this? Output part actually. Yeah, both we have discussed. So we are done with the algorithm part actually. Now before moving on with another algorithm, let's do one thing. Let's discuss the, or let me summarize whatever we have learned so far. There are some 2 to 3 points or 3 to 4 points that we need to discuss, and we have to know this at any cost, right? So this is fine. The first point here would be the Bloom filter algorithm is space efficient, is space efficient, and it is probabilistic data structure, right? It is probabilistic data structure. Sorry about that. So Bloom filter is a space efficient probabilistic data structure. Which is used for set membership checking. Which is used for set membership checking actually. Mainly it is used for set membership checking. Yeah. So just remember this. This is one of the things. Next, let's move on with the further things. The second one here. So it guarantees no false negatives, right? Never says not present when it is, right? So it guarantees no false negatives actually. Yeah, this is one of the things. The third point here would be, so it allows false positives may say present when it isn't. Even if it is not present, it may say it is present, right? So it may say it allows actually false positive. Just remember this one. It is one of the cons actually. Yeah, it doesn't say it is not present at all. It might say even if it is not present, it will say present. Similarly to the proxies that you put, right? Anywhere. So this is fine. The fourth one, proxy attendance I was speaking. So this is fine. The final one is common use cases, right? Common use cases are it is used in the databases, right? So it is used in the databases, especially it's used in the Cassandra, right? Cassandra. Also, it is used in the caching actually. It is used in the caching. Caching in the sense we will be making use of it in the Redis actually, right? So we will be making use of it in the Redis, right? So we'll be making use of it in the DB, nothing but Cassandra. It's used in caching as well, nothing but Redis and large scale systems as well, right? So we mainly make use of it within the Google Big Table, right? So we will be making use of it within the Google Big Table. Just remember this one. So these are some of the applications, right? So these are some of the applications, right? So this you have to know this one at any cost. So these are some of the points I wanted to discuss with you guys. So this one you have to know this one at any cost, right? So this is fine. Let me delete this one. Now we are done with the Bloom filter all go. We are left with only 4 algorithms actually. So, yep, almost we will be covering around 120 algorithms to be precise, or to be correct. We will be discussing actually 114 algorithms, right? So, or 113, 113 algorithms, right? So we have almost completed 109 algorithms. Next, we'll be discussing KD trees and uh, another one, Morse algorithm on trees. Morse algorithm, usually we get the opportunity to implement if you're giving the lead code contest. Sometimes you'll get the opportunity to implement the Morse algorithm actually. So now we will be going with a KD trees and Morse algorithm on trees. Next, sorry, we'll be discussing these two algorithms tomorrow, right? So for now, this is it. Thanks for watching, guys.